All right, we're going to do some more examples. We're on page 115. These are like, these problems are like the ones that we did on 114, but of course a little more complicated, a little harder, but here we go. These denominators now have stuff that we can factor. So the other examples did not, but we're going to need to rewrite these in factored form. And I'm going to write this 1 as a 1 over 1 to remind you that this term has a denominator as well that needs to be considered when we are multiplying through by the LCD. So the LCD of this equation is this factor and this factor. This one is the same as that one, so we only need them once, and the denominator 1, which isn't really, it's a factor of everything. So I'm going to multiply through by the LCD, which is 3 times c plus 4. And I'm going to see that these two, this denominator cancels in its entirety with our LCD, so that just leaves me with 4. However, 1 doesn't cancel anything, so I have to multiply this numerator by the entire LCD. And this term on the other side of the equal sign, the c plus 4's cancel, and I have to multiply the 3 times the 2c that's already there, which is 6c. So this becomes 4 plus 3c plus 12 equals 6c. We're solving for c, so I will subtract 3c from both sides. That leaves 3c here and 16 here. Divide by 3, and you get c is equal to 16/3. And that's our answer for this one. Second one, switch colors here. Again, I am going to see that this is the difference of two squares, so before I figure out what the LCD is, I want to look at it in factored form. So that's x plus 1, x minus 1. So this term is the same as this term, so we don't need him twice. We need an x minus 1 and an x plus 1. So that's going to be my LCD. And that's what I'm going to multiply this entire equation by. So this x minus 1 cancels here nicely. That leaves me the x plus 1 to multiply the 3 by. Nothing cancels with this one, so this piece is x plus 1, x minus 1. And on the other side of the equal sign, this x plus 1, x minus 1 is our LCD. The entire thing cancels, and we just have a 12. All right, so to clean this up, I'm going to distribute 3x plus 3, and then I see double distribution that I need here. So when I do that, you can double distribute, or you might just say to yourself, well, that's the difference of two squares. That's this guy right there. So I can just write him like that. And now I am closer to getting something I can solve. I'm going to put it in standard form, x squared plus 6x, and that's going to be minus 1. Let's see, did I lose a 3 here? Yeah, no. All right, x squared, it's not plus 6x. That's what I did. So it's x squared plus 3x, and this is plus 3 minus 1, which is a plus 2, minus the 12 that's coming over from the other side, so that is minus 10 equals 0. And now I'm looking for factors. I'll do the easy AC method. What multiplies to negative 10 and adds to 3? I see 5 and 2. So it would be a positive 5 to get that 3 positive, and a minus 2. Set each factor equal to 0, and you get x is equal to minus 5, and x is equal to 2. And these are our two answers. So now we come down here, and we are now at the point where we are going to start checking our answers. We have not done that, but that will be expected of you. And we are going to end up with answers that are mathematically correct, but that are extraneous, that we have to throw out, just like we did when we were solving rational or radical equations. So if you look at this first problem, I'm going to think of that 3 as 3 over 1. My LCD is a minus 5. So I'm going to multiply through And when I do that, the a minus 5 cancels, and I'm left with 4a plus 3 times a minus 5, because nothing cancels down here, equals 3a plus 5, because the a minus 5 cancels. So clean it up, and you get plus 3a minus 15 equals 3a plus 5. We're going to get our a's together. So I've got 7a over here, and subtract the 3 over there. That leaves me with 4a, and move the 15 over there. I get 20, divide, and I get a is equal to 5. And that all looks fine and good until you go back up to your original equation and you say, when I look at this denominator right here, or the one on the other side, and I plug in my answer, I get 0. And 0 cannot be a denominator. You cannot divide by 0. So really, all we're looking for is a solution that when you plug it in, it makes 0 in the denominator. Because remember, a solution of an equation has to work. It might be mathematically correct when you solve it, but it's got to work. It's got to make a true statement when you plug it in. So in this case, we have to throw out the x5 and say this is extraneous. And because we have no other possible solutions, our answer to this guy is no solution. And we'll do some more of these in our very last video coming up. See ya next time.